Welcome to the third lecture of electronic circuits design. In this lecture, we'll study decibels. Decibel is a way we can represent power, voltage, and current gain in terms of dBs, decibels. But we have to compute a term that is based on logarithm. So for power gain, this is 10 log AB, or this power gain P out over PI can be represented as V out, I out over VI, II, or V out squared over R, or I, or V in squared over R. So AV, sorry, this is not AV, this is AP. So AV in dBs, this is AP in dBs, can be represented as 10 log V out over VI squared. This means that this can be written as 20 log V out over VI, or 20 log of AV. So AV in dBs can be represented as 20 log. It's the same way we can represent, it's just another way of representing gains in terms of logarithmic quantities. And we know that when we apply this logarithmic quantity, we call it dBs. We call it dBs, right? So the same expression can be computed for current, where AI in dBs, AI in dBs can be represented as 20 log of AI. It is left as homework for my students. It can be proved in a very similar way like we have done this. It's a homework for the students. A 0 dB reference is a point at which we have the output having power or voltage or current exactly equal to the input. Input power is the same as the output power, output voltage is the same as the input voltage, and output current is the same as input current. For that, AP in dBs or AV in dBs or AI in dBs, they are all equal to 0 because log of a 1 is a 0. Because the gain is 1, the output power is the same as the input power, the gain is 1, that is why, since the gain is 1, that is why the log of value 1 is a 0, all these gains are 0. And from this reference we can measure different other gains. And for all gains for amplifiers whose gains are, for if AV or AI or AP they are greater than 1, we have positive dBs, and if they are smaller than 1, otherwise we have negative dBs. If gain is less than 1, this means the output is less than the input. In that case, we have negative dBs. Right. Critical frequency is yet another topic. We know that for all amplifiers, we have a frequency response like this. This is gain. For simplicity, it is represented as gain, can be a power, voltage, or current gain. And this band is called mid band, at which we have some gain. If critical frequency Fc is the frequency at which either AP at Fc is 0.5 times the AP in mid band. If the power gain AP in mid band is AP at Fc, this is 0.5 times AP. And if it is AV at Fc is 0.707 times AV. This is 70% of the AV that we get in the midband, and they both are minus 3 dBs. We can verify this by putting them in their respective formulas. The formulas for Computing AV in dB and AP in dBs, we already know those. AP is 10 times logarithm, and if it is left 0.5, reduced to 0.5, this results in a value minus 3 dB, because any gain that is less than 1 will produce a negative value, and AV is 20 log of 0.707. It also produces minus 3 dB. This means this point is 3 dB lesser than, this gain is 3 dB lesser than the gain that we have in mid band, in this band. Right. And then we have dBm. Sometimes we use the term dBm instead of dB. This refers to dBs in when power is in milliwatt. Instead of watt, if it is in milliwatt, we call it dBm. For example, for 32 milliwatt power, we call it, we convert it to a value that is 15 dBm. And for 0.25 milliwatt power, this is minus 6 dBm, because the gain is lesser than 1. So that's all for this lecture, and in our upcoming lecture we will study more about the low and high frequency response of amplifiers. Thank you.